Okay, I will share my screen.
Okay.
Okay. Um, yeah, so this was a harder book than the last one. Do you
Yeah.
do you
Every
feel
time,
ready to talk about it?
no. Every time the guy switches to C, the context just breaks.
Yeah, it's a different programming language. A lot of the concepts are the same. It's hard to read because it's a different syntax. There's different things going on. Um, there are some concepts that don't exist in Ruby, in C. Um, but C is sorry, but Ruby um, does have its history in C. I mean, obviously, it's written in C, but also, the author made sure that everything that you can do in C, you can also be accomplished in Ruby, like programmatically. Um, I mean, obviously, that doesn't cover, like working manually with memory, but it's also a general purpose programming language. It doesn't have the bracket symbols, but the do and end blocks act like the brackets would. Um, how do you wanna tackle this? Do you wanna talk about it, or do you want to let me talk about it?
Yeah, please do. I think I'll try to pick up in the next chapter because this one was kind of hard for me.
Yeah. The other option is just to say maybe this isn't the right book to tackle. Maybe we need to work on another book. But
No, actually, I think the book is okay. It's just that when I went through the book, I was supposed to go through it with like some other resource to explain the C he was referring to. I don't know if that makes sense.
yeah, I mean, we'll go through it. We'll talk about it.
Yeah.
Okay, so how many times he starts off the chapter with this question: How many times do you think Ruby reads and transforms your code before running it? Once, twice, and then the answer turns out to be three times. So this chapter is explaining these three steps that your code has to go through. These series of transformation to take it from um, a bunch of text to something that can be run in in your computer. Um, so these words might not mean anything, in this paragraph, but by the end of the chapter, hopefully, you'll know what it means to tokenize, you'll know what it means to parse, and then you'll know what it means to compile the source code. Um, so uh, when hmm, have you ever worked in a compiled language, or is Ruby the only programming language you know?
I think Ruby and JS, maybe Python as well.
Okay, those are all interpreted languages. There are other languages that require you to compile your code. Um, do you know what it means to compile? code?
No, not really.
Okay, so let's uh, let's take the C programming language, right? And I'm just gonna just do hello world in C. So I'm just gonna copy this code, CD workspace, CDC. Oh, did that not copy? Okay, so you have this file, and the contents of the file are basically just this. It has a main function, and it prints to console, and it prints hello world, and then it returns zero. Anything other than zero would mean that it errored in some way, but zero is basically the default, and it just says, yeah, I exited without an error. Okay, so GCC hello.c hello. Okay, so what I did was I used the GNU C compiler to compile the hello, that file that we just saw, and I told it to output it to a file called hello. So I'm just going to go ahead and run hello. Great. The this when we ran the hello program, it printed hello world to the console, and that's exactly what we expected. Um, what it did though was so the compilation step. Hold on one second. Sorry, I can't type and talk at the same time. Okay, so we're gonna run disassembler on. Wow, that's way more instructions than I expected. Okay, did I do the right thing? Yeah, okay. So, what am I showing here? We had this file. Whoops. We had this file called hello.c. What we
Yeah.
did was we compiled it. The compiler turned it into a bunch of instructions. Now, when you look at the code, it's just a bunch of bits or bytes all in a row. Um, if we try to open that file with a text editor, you see all kinds of like garbage here, right? Um,
Yeah.
it's not something that we can really understand with a text editor because it's turned it into zeros and ones. And those zeros and ones don't make any sense when we see it this way. But those zeros and ones translate to instructions that the CPU can understand. So your processor knows how to do things like add, let's say, or move memory from one location to another location. So if we look at the disassembled code, so the command that I ran was NASM disassemble, and then we gave it the name of the program that we wanted to disassemble, and then because and actually there were just a lot more instructions here than I expected. But you can see that, I div, jump, we have a whole bunch of ads, F word, test. These are all instructions that the CPU can understand. And it's handled directly in the CPU. Each of these like ads is actually zeros and ones in the compiled file. They're just zeros and ones. And the disassembly, all that we did with the disassembly is translate all of those zeros and ones into the instructions that they code to. Back in the day, programmers would write their code in zeros and ones. They would write it in what's called machine code. Machine code is very, very hard to work with. Uh, so so assembly code was invented, and assembly looks, this is what we're looking at. This is the assembly code. It's basically the instruction that we're working with. So we're going to add, what are we going to add? We're going to add AL, and we're going to add this bit of memory here together. Okay. So in compiled languages, and this is what I'm trying to get at, in compiled languages, we have our text code that gets converted into machine code by a compiler. And then when we run the program, like if I just say dot zero hello, and we run that program, that all of those zeros and ones get translated back to their machine instructions. Those machine instructions are fed directly to the processor. The processor takes each of those instructions uh, and produces that the program. Like it runs all those instructions, and that is the program that we're looking at here. Uh, Ruby, Python, and any other interpreted language doesn't work that way. Um, it is uh, it is text. So, we're working with a bit of text, and you have and that there's an interpreter that looks at that text and then understands, okay, what do we need to do with this program? Okay, these are the instructions that I need to generate for the processor. And that there's that happens at runtime. And what I mean by runtime, do you know what runtime means?
Yeah, I think we kind of looked at it when we were looking at the dynamic nature of Ruby from the past book.
Yeah.
Yeah, it came up.
Okay. Runtime just means like it's happening when you're running the program. Uh, when we looked at the C, that compilation, that translation from the words to the zeros and ones that are instructions, that was at compile time, which means before your program even runs, you're already generating the machine instructions that go to the processor, which is why C and a lot of other compiled languages are so much faster than Ruby or Python or any of those other dynamic interpreted programming languages, because all that work to take your text and translate it into machine instructions, all that work happened before you ever even ran the program. With Ruby, you need to generate all these machine instructions while you're running your program, which means that there's an extra layer happening in the background. There's extra processing that means that your program is just going to be a little bit slower. And as we're going to look at in this chapter, it's not just that it's compiling the instructions, it needs to tokenize the instructions first, parse those instructions into meaningful semantics, and then it can compile them into something that can be given to the processor to execute. Oh my gosh, my throat is really dry. I'm gonna take a little break here and grab some water so that um,
Okay.
I can refresh my throat here. Okay.
Okay. Skate knows. He was talking about a computer at the CPU level. Everything is ones and zeros, bytes.
While I'm refreshing myself here, do you have any questions about what I just said?
Um, I think the only one of the things that didn't make sense was the distinction between the ones and zeros, which I've heard of. Like most people tend to reference that, like everything is ones and zeros, and then you talking about the instructions, which are what you printed out in the terminal. So that kind of was kind of confusing.
Yeah. Hmm. Okay. Let's take a step back here and whoa, I did not intend to do that. Somehow I opened the hold on. I'm gonna stop sharing and restart sharing again because I got to a place where I could start drawing, but I didn't know how to exit it. Okay, you can see my screen again.
Yeah, yeah.
Okay, I'm gonna bring up the documentation for the x86 processor because I was just working on this. Okay, so you this is the user manual for a processor. Okay, it's one of the earlier processors. This is Intel's third generation in processor. It's the 8086 processor, and it was a 16-bit processor, which means that uh, the registers it used had 16 ones and zeros uh, as storage space. Do you know what a register is?
No, I don't know. But when you talk about the 16-bit, my current computer is 64-bit. I don't know if that's related. And then
Yes.
others are 32-bit.
Yep. Yep.
Yeah.
So 32-bit means that it's got 32 bytes and ones and zeros that uh, are the basically the space that it can use for storing one thing. Um, okay, so you have um, so the first part. Do you know what a byte is?
I don't know, like a character, I suppose.
Yeah, it's hard to know where to start explaining because because there's just so much. Okay, so a byte is 8 bits. Okay, that's it's as simple as that. 1 byte is 8 bits. 2 bytes is 16 bits. So this instruction manual is explaining, okay, we're storing an instruction, and this is the skeleton that makes up a single instruction. So one instruction is going to be is the first 2 bytes of a single instruction is going to be parsed this way. The first six ones and zeros, so the first 6 bits describe the opcode. The next bit is this direction. The next bit is this uh, word or byte operation. Okay, the next 2 bits are the mode. The next 3 bits make up the register. The next 3 bits after that are the register operand or whatever. So what it's saying is basically all of these spaces here are for zeros and ones. And depending on the zeros and ones that you have here, that will be a different instruction that you run in the processor. So if we look at a move command, and a move command is basically saying, I'm going to move this number from one place to another. And in our processor or in our machine, you could be moving from from a register to a register, or you could be moving from like a register to memory. And so what this is saying is if it starts with 1 0 0 0 1 0, then it's going to be a register to memory move, or sorry, a register to register move or a memory to register move. Um, and all that means is that it's going to move some numbers from one place to another. Here, it's saying immediate to register memory. So if you see 1 0 0 0 1 0 0 or whatever, like it has the numbers here, and then it has tables for interpreting what the W means. It has in tables for interpreting what the mod means. So if you look up here, uh, this is the W and the D that we saw. If it's 0, it means one thing. If it's 1, it means another thing. And so in your computer, in memory, you have a whole lot of ones and zeros. And those ones and zeros map logically to instructions that the computer can do. So these ones and zeros mean a move. This other set of ones and zeros mean you're going to push uh, memory into a register. These ones and zeros means you're going to pop memory out of the register. Um, so you know you have like addition. The That's one of the basic operations of the processor. And so if you see 0 0 0 0 1, you know, all these zeros, you know that it's going to be this instruction. Okay. Does that make sense?
Yeah, yeah,
Okay. So depending on the ones and zeros, it's going to be a different instructions. And so programmers used to write out the zeros and ones manually. And then they decided, well, hell, this is way too hard. And so they created assembly language. Um, okay, let's take a look at some sample assembly. Whoops. Hmm. Okay, so this assembly code was for the 8086, and basically it's just saying move. This is the instruction, move,
Yeah.
and then this is the name of one register, and this is the name of another register. And this command is basically just saying, let's say in Ruby we said A set to B, or in this case CX set to BX. It's more or less just an assignment. That's the direct translation of the above code is is more like is like this. You're assigning whatever is into BX, you're assigning it into CX. Okay.
Yeah.
And you have a lot of other, complicated assembly instructions, but that's basically it. And these moves, like like we saw from here, from the manual that we were looking at, these translate directly to 10010 0 0 1, and then you have some other 0 1s, and I I don't know how to translate this, but this is the basic idea. These This text that you see up here is directly translated to these zeros and ones. And so this translation has to happen at for us in Ruby, it has to happen at runtime when your program is running. So the first thing that has to happen is that we have to go character by character. And actually, maybe I should be looking at some Ruby code because this is assembly code. Um, okay, so when your Ruby interpreter, whatever Ruby interpreter you're using, when it starts up, it at first has to start lexing your Ruby file. And what that means is that it's going to go character by character by character um, until until it encounters something interesting. Here we have a space, and that's interesting because it means that all the characters that we've read so far are a are interpretable are one token.
Yeah.
And so next, so that it's gonna give one token to the parser, and then the parser is going to take that token and say, what kind of thing do I have here? Is this a keyword? Is this a function? Is this something else? And what so what type of thing is this word? And then after you have all the types defined, um, so uh, actually we should probably follow the text for this part of it. Okay, so here, it's telling us to write this code, Ruby simple, and that's here. So simple.rb, that's what we're looking at. And it's saying, okay, we have all these characters in our file. And so the Ruby interpreter is going to start with the first character, and it's going to keep going. Uh, it's going to find a one, it's going to find a zero, and it's going to find this dot. Now, this dot could be one of two things. It could be a decimal place for a floating point number, or it could be a method call, like here, like And in this case, it is a method call. We're calling dot times on this. So basically, it's going to keep going until it has found a reason to say, okay, this whole thing is a token. So the 10 is a token, the times is a token, the do is a token, the n is a token, and it's going to keep going until it finds all the tokens. Um, and I should say, while this is happening, after it finds a token, it passes that token to the parser. Um, okay, so after it found the dot, it passed the one and zero to the parser, and the parser took a look at the one and zero and said, "Okay, what type of thing is this?" The type of thing is an integer. It's a type integer. Great. So now what am I going to do? I'm going to keep going until I've found another token. So af- after it finishes processing this times, it says, okay, what kind of thing is times? It's an identifier. And an identifier in this case just means the either a method name or a variable name. Okay, keyword do. So do is one of the reserved keywords in Ruby. And later on, it's going to tell you where to find the different keywords, and they're defined in. Oh well, we'll see. I've forgotten the name of the file. Um, okay, so it's going to keep going until it's parsed. Uh, so it's tokenized everything and it's parsed everything. So the tokenization basically says this is a logical different thing. And then the parser just says, okay, what kind of thing is this? Okay, so here it's telling us to do this exercise where we're gonna use Ripper to parse our code. Okay, did you actually run this code, or did you just read the book?
No, I just read the book. Actually, Nelson, I don't know your screen sharing. It kind of froze back there.
Okay, I'm gonna stop share and then share again.
Yeah.
Okay, do you see my mouse moving?
Yeah.
Okay, so IRB, I'm just gonna run this code, okay?
Okay.
So I'm gonna copy, paste. I have to delete this stray W. Okay, so uh, ri- um, a tool called Ripper makes it very easy to see what tokens Ruby creates for different code files. So we basically, in our interpreter, we required Ripper and pretty print, and we basically said, okay, this is the code. I'm going to define a string. So this is a multi-line string, and this is the start of a multi-line string, and this is the end of a multi-line string. So the string that I have, um, do you know what a string is?
Yeah.
Yeah, so just this text, right? So I'm gonna run this text through the lexer, and then Ruby is going to tell me what basically list everything that I parsed. So here we have this 1 0, and it parsed it as an integer, a dot, which is period, times. which is an identifier, this blank, which is a space. So these are all the this is a list of all the tokens that it found. These strings are all the tokens, and then the yellow here is the basically the what it parsed as the types. And you can see like this is what's going on under the hood when you run your Ruby program. Um, and we're looking at it in an interpreter right now, which means that this is happening on the fly. This is uh, it's not uh, it's not like we compiled this file and we're looking at a decomp decompilation. This is the interpretation of the text that we just printed out. And that's what happens with all your Ruby files. Because all your Ruby files, you're just putting in text, right? And that text has to tell the CPU to do something. So first we have to grab all the tokens, then all the parsed. We have to parse all the types, and then we have to send all of this information to a compiler so that it can know how to turn all of these words and types into the ones and zeros, the machine instructions that the CPU can actually run. Okay, so here it's basically just saying, okay, this is the code we have. This is what it parses as. Um, I mean, it's the same thing with all of these other instructions. Sorry, let me drink some more water.
Yeah, actually, Nelson, we have like 1 minute 50 seconds. I think we should join another call
Okay, I'll
and
stop
then
this and then
continue.
join the other one.
Okay.